Okay, we need to know the definition of and be able to test for continuity both graphically and algebraically. So as I'm looking at this graph, where is the function discontinuous? And the function is not continuous at x equal -1, and where it fails the test, remember that to be continuous it has to meet the requirement the limit as x approaches a to be continuous at a of the function has to equal the function value there. That's our requirement for continuity, but remember that requirement implies two other things must have happened. The first thing that must happen is the limit as x approaches a of f of x must have existed, so exists, and the second thing that must have to happen, and I didn't leave room up above so I'll put it right here, is f of a exists. And then if you have both of those conditions and you meet the third condition where those two things equal each other, then we have a continuous function. So at -1, well, as I approach from the left-hand side, I'm approaching a value of 3. From the right-hand side, I'm approaching a value of 2. So the limit does not exist, and so it is not continuous. So I'm listing the places where it's not continuous, and I'm telling you how it fails. On a test, it would ask you where it's not continuous, and according to the definition, why. So you would need to say the limit does not exist there. Okay, another place that is not continuous is at x equal 1. And the limit does exist there. As I approach from the left and the right, I get 4. The function does exist there. It's 5, and that's the problem. This fails condition number 3, which says the limit as x approaches 1 has to equal the function value at 1, and it does not. Okay, as we look at another place where it is not continuous, that's going to be at x equal 3. And a couple things going on here. The limit does not exist. As I approach 3 from the right-hand side, I approach infinity. From the left-hand side, I approach -infinity. The limit does not exist at 3, and therefore it is not continuous at 3.